Every day, the world generates millions of tons of waste, creating one of the biggest environmental challenges of our time. Plastic bottles, food scraps, paper, metal, and electronic waste often end up in overflowing landfills, polluting the environment and wasting valuable resources. But China has taken a different approach. By investing in advanced technology, modern recycling facilities, and large-scale waste management infrastructure, the country has built one of the world's largest recycling and resource recovery systems. Although challenges remain, China's efforts demonstrate how waste can be transformed into valuable materials, clean energy, and economic opportunity instead of becoming an environmental burden. With a population of more than 1.4 billion people, China generates an enormous amount of municipal waste every year. Rapid urbanization, industrial growth, and increasing consumer demand have made waste management a national priority. Recognizing that landfills alone could never solve the problem, China introduced comprehensive waste sorting policies and invested billions of dollars in recycling plants, waste-to-energy facilities, and smart waste collection systems. Many cities now require residents to separate their household waste into 4 categories: recyclable materials, food waste, hazardous waste, and residual waste. This simple step greatly improves recycling efficiency because materials arrive at processing plants with far less contamination. The journey of waste begins at homes and neighborhoods. In many Chinese cities, residents use designated bins for different types of waste, while collection vehicles transport each category separately. Some communities even use smart recycling bins equipped with digital identification systems that encourage proper waste disposal. Once collected, the waste is transported to highly automated sorting centers where advanced technology takes over. Conveyor belts move thousands of items every hour through a series of machines that use magnets to remove metals, optical scanners to identify different plastics, air separators to sort lightweight materials, and artificial intelligence to recognize recyclable items with remarkable accuracy. Robotic arms then separate valuable materials at high speed, making the recycling process faster and more efficient than traditional manual sorting. After sorting, each material follows a different recycling path. Plastic waste is cleaned, shredded into tiny flakes, melted, and transformed into raw materials that manufacturers use to produce new bottles, containers, clothing fibers, and countless everyday products. Paper is pulped, cleaned, and recycled into newspapers, cardboard, and packaging materials. Metals such as aluminum and steel are melted and reused repeatedly without losing their quality, saving enormous amounts of energy compared to producing new metals from raw ores. Glass is crushed into small pieces, melted, and manufactured into new bottles and construction materials. Meanwhile, food waste is processed into organic fertilizer or converted into biogas through anaerobic digestion. This renewable gas is then used to generate electricity and heat, turning kitchen waste into a valuable energy source instead of allowing it to decompose in landfills. Not all waste can be recycled. Materials that cannot be recovered are often sent to modern waste-to-energy plants, where they are burned under carefully controlled conditions. The heat produced during combustion generates steam that powers turbines and produces electricity for thousands of homes. These facilities are equipped with advanced air pollution control systems designed to reduce harmful emissions while significantly decreasing the amount of waste sent to landfills. By recovering energy from non-recyclable waste, China reduces landfill dependence while generating additional power for its growing cities. Technology is the driving force behind this transformation. Artificial intelligence, robotics, big data, and automated monitoring systems work together to improve efficiency at every stage of the recycling process. Smart sensors optimize waste collection routes, reducing fuel consumption and transportation costs. AI-powered cameras identify recyclable materials within milliseconds, while robotic sorting systems increase both speed and accuracy. At the same time, Public education campaigns encourage citizens to separate waste correctly, proving that successful recycling depends not only on technology but also on public participation. China's recycling system continues to evolve as new technologies emerge and environmental standards become stricter. Although challenges such as plastic pollution, regional differences, and recycling quality still exist, the country's investment in modern waste management has shown that large-scale recycling is possible when supported by strong infrastructure, innovation, and public cooperation. The most important lesson is that waste is not simply garbage, it is a valuable resource waiting to be recovered. Every recycled bottle, every reused metal can, and every kilogram of food waste converted into clean energy helps conserve natural resources, reduce pollution, and build a more sustainable future. As the world searches for solutions to the growing waste crisis, China's experience reminds us that with the right technology, responsible policies, and public commitment, yesterday's waste can become tomorrow's opportunity.